Hello YouTubes, do you remember this? New York Central Rotary Snow Plow? I converted this to DCC because I thought it would be nice to be able to control the speed of the spinning rotor at the front. Well, that was a waste of time and a waste of a decoder, so I ripped it out, so now it does nothing. So today I'm going to convert it back to DC, but I'm going to add a resistor to control the speed and also a bridge rectifier so we can use it on both DC and DCC. For this little project, we are going to require some resistors or potentiometers. Potentiometers are basically just adjustable resistors, so probably best to use these on this occasion because we actually have three things on this that I need to power and they might require different voltages. We will also require a bridge rectifier. The ones I get come in these handy little rolls. They are absolutely tiny, so they will fit anywhere. They convert the AC signal to DC signal, or DCC power to DC power if you want to keep it basic. And finally, we are going to need a flashing orange bulb, because the orange bulb that's currently in here, the flash was controlled by the decoder, which is no longer in it. Hence, we need the flashing bulb, and that requires a very specific amount of voltages. Okay, right, let's get inside and see what disaster I left when I tore the decoder out, shall we? Now, I think it just clipped in and out. Just pull it apart. Yeah, I can see a tab there. That's all I can see. Oh goodness, let's see. I'm not going to pull it with the ladders. That's how you break things. Stretch it out. And out it pops. Excellent. So that's what we've got inside. Oh, it looks like I replaced the motor. I can't even remember doing that. So that's one of my cheap $1 motors from AliExpress. 5-pole. It's really good, really smooth and quiet. So let's see what we have then. Oh, I've still got the harness in here for a decoder, just in case I change my mind. So I'll be cutting that off. The grey wire should be the negative for the motor. Orange should be the positive for the motor. And these two wires coming up here are our right rail, which is red, left rail, which is black. So I shall cut these down, take this out the way just now. We'll figure out the lights later. Let's concentrate just on the power coming in and controlling it with our bridge rectifier, and then we'll move on to the potentiometers. And we'll use them as and when required, okay? Right, where do we start? First of all, I thought I had a power pickup at the front of this, and obviously I do not. So I tell you what else we could do. We could also add a capacitor. There's plenty of room in there, so why not? So let's get started. We need to convert the power coming in, which is left rail, right rail. We need to convert that to always work in DC, and that's what the bridge rectifier is for. These are very, very tiny, but basically you've got power coming in, and it doesn't actually matter which way around you connect these two on those four little connectors there. Power coming in doesn't matter, but power going out towards the motor has to be positive and negative. It is marked there. So I will hook them up there for now. Need to be really careful because these are so delicate, you can easily fry the inside of them. Let's get our little claw in the action. Hook that up. Let's do it upside down. It's going to be easier to do it upside down. Not that you guys can tell the difference. Okay. And I want to keep these as short as possible so that we don't have any arcing, cross-contamination, whatever you want to call it today. Tiny bit of flux in there just to ease everything in. tin these wires. Let's see if we can hook these in. I think what I'll do is I'm going to just give my iron a bit of a clean, because this is fairly precise work here. Get a bit of fresh solder on here. Just give my little ends a little taste. And get our wires on. And try not to overheat them. One on. Oh, I'm going to have to go left-handed. This could be dangerous. Okay. So that is our little bridge rectifier in place. Remember, the power going into the rectifier doesn't matter which way round these wires go. The power out, however, really matters. And once I've got these wires on, I will put a bit of heat shrink over the whole lot, just to keep it all nice and cozy. Okay? So I can see from here that this side here is the positive, and that side there is the negative. So I'll tell you what we'll do. We'll get a bit of red wire, a bit of black wire, and then we'll know for sure what to connect everything to once we seal it up with the heat shrink tubing. Okay? Let's get a bit of flux on there ready. Get my crocodile clip in place. Lovely. Actually, I'm going to take that off and make sure I've got these the right way around. Just so tiny. Let's zoom in. Might actually be easier to see it on screen. There we go. Now you can see it very, very faintly. So the one at the top of the screen has quite clearly got a positive. The one at the bottom's got a negative. Okay. Let us continue then. So let's get our iron. Oh, get them in place again. Red at the top. Oh my goodness, this is so delicate. We'll get some fresh solder on there. And our black. I should have got bigger bridge rectifiers, but I didn't know what size they were when I saw them in the catalogue on you know what I mean, the online shop. Right, let me find a bit of shrink wrap to go over this, just to keep it all nice and safe, okay? I mean heat shrink tubing, shrink wrap, I'm not making a sandwich. Okay, let's see which one of these ones will do the job. Hoping the black one will do the job, but I don't think it's going to get over the bridge rectifier, unfortunately. Nope. Next one up is the red. It's a wee bit loose, but I don't have anything in between. Okay, so I need about that much. Slide that down over the top. Okay, let's get that shrunken down. Come on, shrink more. Shrink like your life depended on it. This is the worst heat shrink I've ever used. Doesn't have to be mega tight, it just needs to not move about. I think that's okay actually. Oh, okay, I'm getting the knack. Just need to be a wee bit bolder with the flame. Okay, that looks fine. Okay, we can move on. Just a little bit of charring there, that's okay. So what I might do actually is tuck this down here, out of sight, out of mind and all that. And that can live there. Kind of just glue that in place for now, I think, because we don't have to deal with that again. The next thing will be connecting these two. I'm not sure yet. Let me get that stuck down, see you in a sec. Okay, that's our rotary snowplow now converted to DC power, regardless of whether it gets DC in or DCC in or AC in. Those two wires there are going to pump out DC power, but it's going to be either variable voltage if it's DC or up to 14 to 18 volts in DCC system. So we need to regulate that, and we want to kind of bring it down to 12 volts for everything really, because that's what all the little components usually rated to. So that's what we're going to do next. But first, I'm going to add in a cheeky wee capacitor to act as a keep alive. And the way this works is, and it is polar specific, so the red wire goes to the positive side of the capacitor and the black goes to the negative, and it's usually pretty clearly marked there. So this one here, and it's also the shorter of the two legs, is the negative. So the black's going to connect to that, the red's going to connect to the other, but then the wire is going to come back out of there again and carry on its little journey to power things. The way the capacitor works is the power's coming in, it fills this with juice, and then it holds the juice for a wee while, and then if there's a power outage or a dead spot somewhere in the track, it'll release that energy and continue onto the lights and the motor and stuff like that. Okay, so that's how it works. Pretty straightforward really. This one is 16 volt 2200 what they called Pharaohs, I don't know, it begins with an F. Okay, so that's what I'm going to do, wire them in there and then continue the wire coming out to go into our next things. Let me do that quickly. And that is our capacitor installed, but now I need to take another couple of wires off of that. So I will just use the wires that I just snipped. Let's not waste. If I can find the little black wire, and we'll get the black wire and the red wire connected to the other side of this to continue the little journey of the power, okay? Okay. That was a wee bit of a struggle. Right, let's see where we're going to put this little capacitor now. It's still got loads of room down there, so I think we will just position that here. Let's make it round this side for a bit of variation from where the wires are going. Oh yeah, right in there, that'll be nice. Black wire will come, no, because I would quite like it going that way around, because the black wire wants to go to that side of the motor. So let's do it that way. Oh no, that doesn't really matter, because the red wire is going to that side. Horses for courses. Yeah, I think we'll just put it there. Black wire can go down there. Red wire can go up there. Awesome. Let me just glue them in place then, or glue the capacitor in place. Okay, that is our capacitor glued in. I did remember to move it back a little bit because we need access for that screw, because that's what holds on the lower truck, or the truck, the rear truck. Okay, moving on to the next thing, which will be dividing up these wires, because we need to turn these wires into 6 wires. 2 for the motor, 2 for this, for the headlights. Wait a minute, headlight. Oh yeah, the headlights are in the body, so I need to take care of this wiring. And 2 for the little flashing light. That's next. Potentiometers. Before I continue, I must stress this is not a tutorial, okay? If anything, this is a how not to video. I am not a professional, I'm barely an amateur, okay? So whatever I do, I am fully responsible for. If it blows up, then that's my fault. Don't follow what I do. Do your own research. This is just how I'm doing it. Okay, enough of that. Let's go on with it. I'm going to split these 2 wires into 6 wires. So I'm going to have 3 blacks and 3 reds. Well, when I say 3 reds, I'm actually going to have 2 reds and 1 blue, because the positive for one of the lights in there is actually blue, but 3 blacks. Okay, let me get them all wired up together. Size is not important at the moment, we can trim them down as required. It's looking quite complicated in there. Maybe I should have just put a decoder back in. Let us continue. So we now have 3 negative wires. They go to the negative on each component. So 1 negative to the negative of the motor, 1 negative to the negative of the flasher, 1 to the negative of the headlights. That's what the black ones are for. And we will be attaching the variable resistors or potentiometers to the red wires. So they correspond with the blue one to the blue positive, the skinny black one to one of the black, doesn't matter which one because they're all going to the same place. We have 2 sets because I've got 2 headlights in the front of this. So the 2 red wires will go to another potentiometer. No, actually we don't need a potentiometer for the headlight because they've already got built-in resistors in there. If you can just see in there, they've got each 1000 ohm resistor, so we don't have to mess with the big thick black and red wires, okay? They can just get wired straight to one of the blacks, one of the reds without a potentiometer. So we just need a potentiometer to control the speed of the motor and one to control the flash, which is the little blue and black one. Okay, let's start with the motor. That's a big one, right? So we'll start with the easiest one first, the motor, because the wire is right here, the black one that is. We're just going to connect that directly to this side of the motor, right there. Let's cut it down a wee bit, we don't need wire everywhere. A wee snip there, a wee strip here, a little bit of flux and a little bit of solder. You can go straight on. Like so. So that's the negative of the motor. Positive of the motor, instead of connecting one of the power ins directly to the motor, we are going to intercept that with one of these tiny little resistors. So what we're doing here is, these are funny little resistors. Normally the connectors are all in a nice little semicircle, but these are, as you can see, in a triangular. Generally though, I found, and don't quote me on this, but the centre one is usually the input. So that's going to come from the power of the track. So that's going to go onto the middle one, if you like. And we can actually use either one of these because the only difference is when you turn this little dial here, if you turn it left and it's connected to that one, it might go slow. Whereas if you connect it to that one and turn it, it might go slow. So it doesn't really matter either way. We're going to be able to turn this left or right, clockwise, anti-clockwise, doesn't really matter. So I will connect the input to the center and then another bit of red wire going from one of them to the motor. This really is the definition of a hot mess. Okay, bit of a recap then. Power is coming in off the rails, right and left. Goes into the bridge rectifier, sorts it out, turns it into DC power. So we've got the positive of the DC power going into the capacitor, negative going into the capacitor, then it comes back out again, goes into the bridge rectifier, which is currently set to the middle. As you can see, that can rotate. And depending on which way round these pins are configured, either left is going to speed it up or right is going to speed it up, but we won't know that until we put it on the track, because there was no indication on this little this little pot that told me which way round was going to be the fast or slow. So the positive comes out of the pot, it goes into the positive of the motor, negative of the motor goes along here and goes back into the capacitor and back through into the right hand rail. So let's test that out for now. We'll keep these wires out the way. There for the lights, but we should be able to put this on the track, my test track, in both DC and DCC and see if it works. Let's give it a go. So this is my new loco tester. It is very cool. We're currently hooked up to DC power. Let's give it some juice, see what happens. Giving it some power. Now that's full power and we've got nothing. So let's play about with that little potentiometer variable resistor and see what if we can get some power out of this. Whoa. Okay, so I want to be able to run it slow enough that we can see something happening. Unfortunately, I think the potentiometer I've got isn't strong enough. I think it's burning up. Yeah, I can see smoke. Can you see smoke? We might have to change that. Or add a resistor in, an extra resistor in before it, or in line with it. So let's switch it off before we burn it out. Back to the drone board. So unfortunately, I think that those little potentiometers that I got, I just don't think they can handle the power. So I am going to remove that little pot and just replace it with, we'll start with a 1000 ohm resistor. And if that isn't allowing it to spin, or if it's spinning too fast, we can go up or down. I've got plenty of resistors to choose from. So let me quickly swap that out and we'll see you back down on my little test. Rolling rail. Yeah. Okay, we are back and this is my 1000 ohm resistor. Let's see what sort of speed it turns at, if it turns at all. That's actually perfect. That's full speed on DC. So that is maybe not even a quarter speed. So it would probably be running a bit there. That's pretty good. I'm happy with that. And that's full power. What happens when we lift it off? Because it does have a capacitor, although capacitors don't really work on DC power. It spins for a little bit. Right, let me get this back on. Ow! Just burnt myself on that wire there. Don't know how much. Oh, I probably burnt myself on that. Because resistors do get hot, which is why you got to insulate them. Definitely nipped myself on something. Must have been the resistor. So, be careful guys, resistors get hot. Anyway, let me switch over to DCC. Oh, I think I need to go to hospital, that was really sore. Okay, we're about to hook up to DCC. However, it's either on or off with the DCC system. You can't control the speed. That's why I'm hoping that that resistor runs at just the right speed. So when I touch this clip to this bar here, we should get power. And we do. Oh, that's perfect. And I'm more likely to be running this on a DCC system anyway. That is perfect. Really happy with that. Nice and quiet. So let's see. Hopefully the capacitor should actually work better this time. Nah, not really. Oh, sparks. Goodness, look at all those sparks. And I didn't think I was getting pickups from the front, but I guess it's coming through the chassis. Anyway, I am happy with that. Job is a good one. So we need to get on with the lights and the headlights and the flashy light. Okay, I went ahead and shortened those wires, put a bit of heat shrink over the top. Oh, which I need to shrink actually. Hold on. Okay, that is protected. That can get tucked down the side there. So let us do the flashy light first, because I know that the headlights will work. They're already pre-resistored, so they'll be absolutely fine. However, I'm not sure if... Oh, you know what? I just had a brain fart. The bulb that I've got in here, I was going to use a... I know I wasn't going to use this bulb because it doesn't flash, so I was going to replace it, so I didn't actually need to make the wires blue and black. I should have just made them black and red. Oh well, they're here now. So let's pretend that this blue wire is actually a red wire. And temporarily we shall hook this up to my new flashing yellow light and just see if it flashes, or if we have to add a resistor. If it stays on constantly, it's getting too much power. If it doesn't flash at all, it's not getting enough power. And if it's not getting enough power, there's not a lot we can do, to be honest. It's more likely to pop with too much power, to be honest, but I guess we'll find out in a sec. Oh, that didn't bond very well, did it? For goodness sake. That's why I always use flux. No excuses. Okay, black wire to black. Just need to be careful we don't touch these together when we're testing. Okay, back to the test track and see if we have a flashing light. As before, we will start with DC power. So it's barely giving it power and it's flashing. More power. It's whether or not it continues to flash or pops when I go full speed with DC. More power, more power, more power, more power. Oh, still flashing in full power, but not quite the same rate of flashiness. You can see it better there. Okay, turn the power down a wee bit. It's much the same, to be fair. And it pretty much stays flashing all the way. So that is perfect for DC operation. Let's switch over to... Oh, did you see that? The capacitor is working. Full power, full power, full power, and off. Yeah, that stayed flashing for a little bit. Now, the good thing about the bridge rectifier, it means that I can actually have this running and then switch it to the opposite direction and it should still work. So that's it going in reverse. Normally if you did that on a DC track, the lights would just go off. So it works in both directions, which is the beauty of the bridge rectifier. Okay, let's go on and try DCC. The moment of truth. Will DCC make that light flash? We already know that it's going to spin at the right rate, but is it going to flash? Oh, almost. It's almost flashing, which means it's getting a wee bit too much power. So I am going to quickly change that resistor to maybe an 800 ohm resistor and see if we can get it to work. Actually, let me think. No, we need to go up with the resistor. So a higher resistor to reduce the amount of power going to the bulb. That's what we need to do. Hold on a second. This bulb already has a 1000 ohm resistor in it. So it's possibly too much resistance. However, let's err on the side of caution, and I'll stick in maybe a 200 ohm resistor in line, you know, on top of that resistor, and see if it does the same. If not, we'll have to remove that 1000 ohm resistor and put in something less. It's all very complicated. Right, let me give it a shot. Okay, we now have an extra 180 ohm resistor there. Couldn't find a 200. Let's see if it's made any difference. Oh my goodness, I heard something fizzling. Oh no, it's not, it's just the motor spinning. Right, so we're not getting flashing. So I think we need to go down the way with the resistance, unfortunately. So I'm going to take out the resistor from this bulb here, which is annoying, and put in an 800 if I can find something like that. I'm having zero luck finding the right resistor, so I had to go for a 510. What a stupid pack of resistors I got, right? I've got nothing between 510 and 1000 ohms, so hopefully this will work. We are on DCC. It's been so long I've forgotten. Right, here we go. Wow, it's still not really flashing. I mean, it's kind of blinking. I'm going to go down resistor even more. Okay, I tried a lot of combinations and I finally got to the bottom of it. 1082 ohms is what it requires. So this is DC power. Flashing away nicely. Let me switch over to DCC power. Okay, DCC power. Hallelujah. So there we go, 1082 ohms for that specific bulb. I'm sure every flashing bulb will have a different resistor requirement. So I need to add a bit of heat shrink over that lot, and then we can finally get onto the final bulbs, the headlight bulbs, and they're just a straight wire, and they will work, I hope. Okay, we are almost there. I just need to connect my flashy bulb and my headlights, but first I need to glue this into its little slot, or its little hole up the top there. Just throwing a little bit of hot glue in there. That's plenty. Poke that through there. Possibly wipe off the extra glue. That wasn't meant to come with it. Poke you through a wee bit more. That's fine, I don't want it sticking away up. It looks hideous when it's sticking away up above the level of the roof. If I don't like it, I can pull it out, stick it in again. Okay, that seemed to have dried frighteningly fast. And we want these wires coming along here. We don't want them interfering with the drive shaft at all. So I think what I might do then is put another dot of glue in there, just to stop it from being naughty. Lovely. Bulb still sticking through. Yes, it is. We're almost there. Almost there. Right, let this set and we'll get on with the final wiring. Okay, that should do it. Hopefully I've got enough room in here to connect all my wires. So these two are my flashing light. We already know where they go. Okay, black can go to any of them. A little bit of heat shrink tubing as always. And the positive side to the blue for the flashy light. Oh, nearly forgot the heat shrink. Okay, now our headlight bulbs. Meanwhile, oh no, I thought I had lost my motor. Negative, but it's still attached. Headlight. Getting excited, we're nearly there. I think I'll just feed the negative wire through. It's getting a wee bit higgledy-piggledy in there. That's better. And finally, our positive for our headlights. One last bit of heat shrink tubing. Thought I was going to forget. Just going to strip that wire back just a little shade more. It's fine. Flux. Wiring complete. Now we need to just find somewhere to put them all. I'm hoping that they can all head to the back, like so, out of the way of all the moving parts, and then this should just clip over the top. Try not to break any ladders, you've been good so far. And we're done. Oh my goodness, we're actually done, finally. Whew! You know, I think that was actually harder than doing a DCC install. Anyway, hopefully it's done now. Let's get it over to the track, and yes, I know I didn't test the headlights, but I'm pretty sure they'll be perfect. See you in the next room. I'll use my handy dandy train mounter railer, whatever this is called. We are on. Let's give it some DCC power. See what happens. Please work. Okay. We have a flashing light. We have headlights, but we do not have a spinning doodah. Spinning now, but only because I started it by hand. That's not ideal. Switch it off. And on. Oh my goodness. It's got exactly the same power supply as the one in the test room. I don't know if I can be bothered changing that. It would probably work just with a bit of vibration when I was going around the track, and then it went off. Nah, I think I'm done. Let's see what it's like going over my frogs, shall we? I think the problem might be that when I added the headlights, it sucked up more of that voltage. So a lesser resistor would have... In fact, the 1000 ohm resistor might have been fine for the flashy light after all. Anyways, let's see what happens. Normal speed. They go a wee bit dim, but they don't go completely off. Normally they would just go completely off because they are LEDs. This is just testing the capacitor. It's better than nothing. That's going to annoy me. I'm going to have to change that. Oh! You know what? I bet it works absolutely perfectly in DC power. Let's give it a shot. Let's switch to DC. Big power machine. Twist the dial. Lights on. Lights flashing. Spinny, spin, spin. Absolutely typical. So we're going to be fine in DC. Let's change direction. That's not direction, that's brake. Direction. Should work exactly the same, and it does. Okay. Right, I'm going to take this back through to the bench. I'm not bringing you with me. Mess about with some more resistors, and hopefully we'll have an actual victory lap at the end of the video. Thank you very much for watching. That was a complete waste of time. Bye for now.